Hello and welcome to the continuous testing meetup. Today with Robin and Aurelian. First of all, we will want to say thank you to Sauce Labs, Trending, and TUI who are supporting us with the time and the people to do this, and especially to Aurelian, who's the host of this. And yeah, if you want to see some previous meetups, just go to continuoustestingmeetup.com. There you can see all the previous videos and find some nice stuff. And now we're starting with Robin, who's talking today about multi-agentic architectures for test automation. So, Robin, it's your stage. Have fun.
Thank you. Cool. So I'll quickly start presenting my screen, and from there onwards, we can get on with the presentation. Okay. I hope my screen is visible to everybody. Okay. So we'll move the Zoom tools somewhere else, make a slideshow, and get going. Okay. Cool. So today we'll be talking about a very interesting topic close to our heart, multi-agentic architectures for test automation. And we'll spend some time in what are agents and what are multi-agentic architectures, and then we'll quickly jump into the code base and take a technical right turn or a sharp turn towards technical side. Okay. So that being said, feel free to post questions in the chat. More than happy to answer easy and hard questions, so we can go in as much technical detail as required. Quick introductions. My name is Robin. I'm the co-founder and CEO at TestZoos. 15 plus years leading product engineering by AI teams, 45 members, drove 10 million ARR core product at Provar, published author and testing at Amazon, and open source contributed projects like Selenium. That being said, let's jump into our topic. So all of us have seen this rise of the agents. So on one box, we are showing a small dev agent, and on one box, we are showing a testing agent. Now, I believe in top-down learning. So the idea is that I can show you an example of either one or two. So in the chat, we'll spend 30 seconds here. Let me know you would like to see a dev agent at play or a testing agent. We'll see a quick demo of it, and then we will go into the technical details of how these things work. That will also stitch the idea together in your head. We don't want to make it boring. We don't want to jump into a lecture mode wherein we just go on and lecture about the theoretical aspects. So we'll wait for 30 seconds, 45 seconds. If you want to see a dev agent at play, put one. If you want to put up, see a testing agent at play, put two in the chat. Okay. Okay. I'm seeing two. So like one, two. Okay. Two votes. We have 21 people. So, okay. Two is rising. 3 out of 21. 4 out of 21. Okay. If we spend too much time on this, then we won't have time for questions at the end. So make hurry. Or else we'll go with 4 votes and my vote and Alexander and or Pauline's vote. 5 out of 21. 6. Okay. Like everybody hates a dev agent or something. Okay.
There are already 8 votes
Oh,
with a 2.
okay.
So
Nice. Okay. Then we'll
maybe
get
you
going.
just scored up and missed 2. I don't know.
Yeah. Oh, okay. Sorry. Cool. I think then we have a lot of people in the testing agent camp, right? So see, for example, we look, okay, at a testing agent right away, and this is an open source testing agent. How it works, what it does, we'll get to that in a minute. But the idea is that you can write a simple test case like this, like go to a website, it is an e-commerce website, and I hope my VS Code screen is visible, wherein we have a small test case about going to Wrangler website and then clicking on a search icon, finding a certain article, applying some filters, and ensuring that one product is displayed. So in this case, you can also write an abstract test case, like you go to Salesforce, create a lead, and then a lead should be created. And the user is redirected to the lead detail page. So in this case, you are telling the testing agent to just create a lead on Salesforce. without specifying the details of entering first names, last names, clicking submit button, or anything at all. So we'll see that, and very quickly on my local, I'll just run this. Again, the same test case can be run for the e-commerce example also that we saw. And you can write your own test cases in natural English language is the idea. So it will start a browser, which is opened on my other screen, and it will start interacting with the UI on its own. The whole idea of an agent is that it comes from the word agency. So an agent should be something which has agency and should be able to autonomously follow the instructions. Instructions such as create a lead, find a product, do a checkout, so on and so forth. It should not wait for your commands to come up. For example, when you talk to ChatGPT, you enter something and then ChatGPT says something. You enter something else and it says something else. So that is not an agent by design. The idea is that the agents can run longer running tasks. So what is this testing agent doing? It is trying to create a lead on Salesforce, which is a CRM, filling in a form on its own, and then ensuring that that form is filled correctly and a lead is created on Salesforce, which is the CRM system. How it works, we'll see exactly in 30 seconds. But the idea is you can provide natural English commands to such testing agents, and they can take care of the autonomous how this autonomous agent. Okay, Max is saying, so what do I need to click? We don't need to click anything. The idea is that you can give this test case to this testing agent. The agent will run it on its own. That is the idea of this multi-agentic system. So for example, when I run this test case, I just have to specify the name of the feature file. Oh, okay. Because what to click to see on the screen? I think you would have to um, click on the speaker dialog. And Zoom is complicated for me as well. But okay, can folks see a Salesforce screen being loaded up on my screen share? Yes. Okay, I found it. Okay, cool. So what the agent is doing is that it is interacting with the application on its own, trying to log in. And even though we had given very high level test case, very abstract test case, the word agent comes from the word agency. So this multi-agentic system has the agency to complete this task autonomously. So that is what we are showing on the screen. So the agent will go figure out where is the new button, where are the forms, which are the fields to be filled. So that is how multi-agentic systems can help us autonomously execute the test cases. How do these work? What are the internals? We'll dive into this right after the form is filled. But I guess everybody can see. Is the LLM locally hosted? Can be. So basically, we are using GPT-4o, but this system can support locally hosted LLMs as well, as long as they can do something called as tool calling or function calling. What is tool calling? We'll see that in 2 seconds on the next slide or so. Okay, so it created the lead. Now it's on that lead detail page, and it will verify the details of the lead that it had entered, and then it will mark the test case as passed. So the whole idea is that you don't need to write automation code, you don't need to write locators and all those things. You can give it an abstract goal, and you can go fulfill the goal on your behalf. So it's your own personal testing agent is the idea. Okay, so it ran that, but back to our slide and back to that question about tools and function calling. So we quickly saw a demo of a testing agent, how when you provided a test case in natural English language, how it can run the test case on your behalf. But wait, what is an AI agent actually? So an AI agent or an agent should ideally have 4 or 5 key attributes. So one is that it should have autonomy to achieve a goal. So in this case, it's a testing goal. Second, it should have some product specific, also have domain specific understanding like Salesforce and memory aligned to it. It should be able to act environment for it or the UI state. And then it should have the ability to use tools like browser, APIs, so on and so forth. So the mental model to correlate all of this together is very simple. Think of an AI agent as a carpenter. A task or to use tools. Now, what are these tools? Just like a carpenter can use a hammer, an agent can use tools like a browser or a mobile or a desktop or even a Tesla car in that case. Because the agent can plan, memorize, and act based on the UI. So that is what an agent is supposed to do. Okay. So moving forward, that is a single agent. But there are problems with single agent systems. So for example, the agent can get overloaded. In our case, let's say in the case of testing, what could happen is that the agent has too many tools. It has access to a browser, it has access to APIs, it also has access to mobile, and we get confused which tool to use based on the context. So, for example, we asked it to create a lead. The agent could get confused. Oh, do I need to start a browser or do I need to start a mobile? Right? The other problem is, okay, the other problem is context complexity. So the context can grow too large. And again, a lot of these large language models have a cap on the input context and the output context. So the context could become too complicated or large for the large language model to handle. And then last but not the least is the need for specialization. So basically, there is a need for the system, and we'll see that why is that, to act in a certain role. In a single agent system, the system can be overwhelmed with responsibility. So that is why we have a few problems with single agent systems. Andrew is asking, since LLMs will respond in non-deterministically, can we guarantee that the same path is followed all the time? I think there are two answers to it. Can we guarantee? Maybe. If we start generating the code, if we start following the same path, if we ask the agent to move in the same way, so that is the strict mode or the hard mode for the agent to run, wherein it follows the instructions to the T. And there could be a softer mode or a more relaxed mode, wherein you give it a goal. And for example, you ask it to book tickets. So it can go through various routes and still book the tickets with the best outcome. So answer is both yes and no. It is how do we instruct the agent to complete the task, right? Back to our slides. There are these problems with single agent systems. And therefore, we've started building out multi-agentic systems. And that is also the title of today's presentation. What are these multi-agentic systems? So multi-agentic systems can be thought of in terms of how we have coded classes or functions in programming language. What they provide is that we can break the whole system into small modules. So multi-agentic systems bring the power of modularization. We can have separate agents doing separate roles, which brings us to the second point, that since we can have multiple agents talking to each other, they can be specialized on a certain task. So the example that we saw earlier, wherein the testing agent was able to open the browser, interestingly, inside that system, and we'll see the diagram in a minute, there's a planner agent which creates the plan. And then there's a browser agent, which is responsible for browsing or interacting with the browser. That also brings the power of control. You can also explicitly control how the agents communicate with each other. And that is why it is a whole lot better than relying on function calling. Basically, function calling is nothing too complicated. It is about how you instruct the system to use tools. Tools could be things like doing a web search or interacting with the browser or using a mobile. So in a multi-agentic system, the idea is that you can have different modules who have vertical specialization on certain tasks, and in arrangement for that, they have tools to be used. Okay. In very simple words, there are multiple ways in how you can implement these multi-agentic designs. Take a deep breath. We'll look at 6 of them, and then we'll zoom in on one of them. Okay. So for example, you could have a single agent. You have a large language model. Think of it like ChatGPT. You ask it to do something, and then you can attach a tool to it. So a lot of us would have seen that ChatGPT and similar systems can do web searches for us. So in that case, that LLM acts as a single agent, and web searches are the tools for it. Okay. Then the other ones could be there could be a network of agents talking to each other. Think of it like your team meeting, wherein three of us join a team meeting and we together try to achieve the goal given. There could be a supervisor pattern, wherein there is a planner agent sitting at the top who gets the test case. It breaks it down into executable format, gives it to individual agents. In this case, for example, there is a supervisor or planner agent, and then it is giving the task to, let's say, a browser agent. It is also giving the task to an API agent. It is also giving the task to a reporting agent. So the browser can communicate with the browser. The API agent can communicate with the API. Once they do their task, the supervisor or the planner asks, hey, reporting agent, collect all the results and give me a final report. So that is one design pattern. There could be other design patterns also, such as supervisor as tools. So not only can you have one agent talk to the other, you can use that other agent as a tool for some other agent. There are also a pattern called as a hierarchical pattern, wherein it makes this complicated tree structure, just like a Christmas tree. And last but not the least is custom and ugly. So you can have a custom implementation of multiple agents talking to each other and trying to solve for a goal. Yeah, we'll share the deck. Okay. So that being said, let's go back to the technical details. Okay. So all of us saw that test case wherein we had asked the agent to create the lead for us on Salesforce, right? So that whole test case ran. Everybody can see my VS Code screen this time, right? Or else we would have to re-explain the whole thing. Okay, I see Alexander nodding. Pradeep also said yes. Cool. So in the terminal over here, right, what we can see is that interestingly in this system as well, which is open source, we'll share the source code, everything will be there. If we search for something called as the planner. So interestingly, even inside this system, there is a planner agent. So what happens is that when we give this test case, create a lead, or when we give this test case, go to any e-commerce website, search for something, the planner agent takes that input, expands it into a plan of execution. Oh, in order to open this website and to search for this product, I should invoke the browser agent. So it will create that task and give it to this junior agent or primitive agent, which is the browser agent. Now, if we search for browser nav, so the next speaker in line is the browser nav agent. He's like, okay, yes, sir. I got the task of opening the browser. I will go and click on something. So that is how these agents communicate with each other. The browser agent uses Playwright as the tool to instrument the browser or to interact with the browser. And that is how that plan, basically the input file, is broken into smaller chunks of tasks given to primitive agents or junior agents like the browser agent who do the task and then report back to the supervisor or the planner agent. I was able to click on it. Or maybe I could not find the search icon. In that case, the planner will say, oh, why don't you try this other thing? Browser will say, sure, let me try this other thing. So think of it as a small army of agents swarming together to complete that goal. That is the whole idea of a multi-agentic system. What we are doing is a supervisor pattern in which we give it some inputs, broken down into executable chunks, given to other junior agents who do the thing on the browser or the API or the mobile or whatever, report back. And then this keeps on happening in loops until that task is completely executed and the test case is run. So in very simple words, that's how we can use a multi-agentic system. Back to slides, and let's see that same thing as a diagram. Every presentation should have some architectural diagram, so we also made one. This is also there on the GitHub repo. The idea is very simple, that as a test author, we provide the feature file. We build the whole system on top of something called AutoGen AG2. So basically, I think I can draw on this somehow. Okay. Yeah. So the tester can provide the feature file. The feature file goes onto the base plane. where there are agents, agents like the planner agent, the browser agent, the API agent, so on and so forth. And we use large language models as the brain for the agents or large visual models. We've also given them capabilities to sense the application and to perform actions on that application. So whenever we ask it to, let's say, do a click on the UI, what it is doing is that it is using its sensing tools, things like getting DOM, getting elements by selector, observing the state of the browser or the application under test, using one of the action tools like clicking or an API call or input or an SQL call to perform that action, which it had received from the planner agent. Once it does that interaction, again, observes the state of the application and then keeps on repeating this loop until that whole input feature file is executed end to end. Once it is done, the results and everything are pushed out in the test execution report. So that is how this multi-agentic system would take that feature file, break it into executable pieces, use sensing tools and action tools to perform that action on the UI. Once all of that is done, at the end of the loop, gives out the results back to the user. Okay, so we close this and move on to the next slide. There's a small feature of SDLC that we strongly believe in. So far, we've seen humans working on requirements, design, implementation, verification, and maintenance. But one of the futures that we see is that humans and agents will work together in mini SDLCs, wherein agents like Bolt for development, Hercules for testing, or Galileo for design will work with humans and will highly parallelize that whole execution to improve the efficiency and throughput multifold. So that is the future of SDLC that we believe in. And a quick side note about tools, copilots, agents, and humans. So this is one way to visualize it. Think of it like a speedometer. So you start from tools. So you would have seen tools like Selenium or Playwright do interactions using things like driver.findByElement.click. So that is the tool. Think of a tool like a hammer. So the hammer can do something, but somebody has to use the hammer to do the thing. Then there are copilots. There are things like GitHub Copilot who can help you complete some parts of code, or maybe even ChatGPT. You can give it abstract instructions, but still, it would not do the planning on its own. It won't have the memory. It can't use other tools, so on and so forth. Brings us to agents like Tezus Hercules agent, which is again open source. You can just tell it to create a lead, and it will create the lead. And last, and the most dangerous are humans, like me and you. When somebody gives us a task, we're like, oh, okay, wait, let me get some coffee. And then we'll try to break this software. So that is the evolution that we see from tools to copilots to agents and humans. That brings me to the end of the slides. We'll share the link in the chat in a minute. You can also find the open source repo for Hercules or the testing agent that we were showing at tezus-ai/tezus-hercules. That's the presentation. More than happy to answer any easy or tough questions.
I will start. I was seeing in your terminal something related to costs. What is it about?
Yeah, 100%. Very tough question. But no, jokes aside, see, when it says that this is the cost, right? So more than the cost, I would push towards looking at, let's say, prompt tokens, right? Or completion tokens. So what happens is that as part of the execution, the agents, planner agent, browser nav agent, all the other agents, they will make LLM calls to decide what to do next, what is the plan, which tool to call, or maybe when the tool is called, how to execute it. So the values that we see over here are the tokens that are being consumed for these LLM or API calls. Okay. Does that answer that question?
We have in chat.
Okay. How the strict mode is implemented. Interestingly, in this agent, we haven't yet implemented the strict mode. So you give it the test feature, and it will ensure the execution of it. So We don't generate code through the agent. The idea is that once you generate code, now you have to maintain the code. So use the agent, you can give it the test case, and it will autonomously run it. How about speed? The issue with end-to-end is long execution time, especially in browser mode. When we add LLMs generation time, I would expect the test suite execution time explodes. Explode might be uh, a little big, but it definitely adds a little bit of time to the whole execution. The idea here is that we are doing a trade-off between the maintenance that you would do with the test case versus giving the test case to an agent who would autonomously run it, and you save the maintenance time of the humans. So a little bit increment in the execution time so that there is low maintenance and the humans don't have to focus on maintenance. Who tests the tests? How can we know that green test suite means the desired actions take place? It is the humans. So basically, humans who write the test case, and then once everything is run, humans would have to do the review and analysis. I think the hard parts of testing are still done by humans only. Does it use model context protocol? Not today. We were thinking of it that we should add an MCP for this. Didn't find time. Again, it's all open source. Please feel free to give us a star, raise a PR. More than happy to merge your PR back. Can we walk through one of the agent? It's code. Yeah, 100%. So for example, if you go to the repo, you can find us over here. So Tezus-Hercules is the repo. And in the core, you can go here. You can find all these agents. So inside the agents, okay, I'll get to Pradeepa's question in a minute. But let's say you go inside browser nav agent. So it will have the system prompt or the meta prompt. It will also have specific boundaries around it and methods to do tool chaining, error management, visualization, so on and so forth. And then this will interact with the tools it has. So the tool browser nav agent will have is the playwright, for example. So then it will interact with that to do that task of browser navigation end to end. So that is how even the other agents are implemented. And again, it's all open source, it's out there. So won't go into like line by line review. Pradeepa is asking what metrics or benchmarks are most effective in assessing whether an agent's validation process is truly robust. I think that's an area of key interest for us as well. So there are these two parts that we focus on. So one is the agent eval itself. So what we do is that even as part of the project here, whenever we do releases, we have our own tests that we run for the agent. Tests including not only e-commerce websites, interactions and test cases on complicated systems like Salesforce, API test cases, visual validation test cases, so on and so forth. And then we keep a track on the success ratio of those test cases. But in general, agent eval is a very quickly evolving field. And then there are custom tools like PromptFoo, which can do not just even agent eval, they can do red teaming for the agents. So that is an area that even we are exploring for our own agent and for agents in general. Okay.
Hi, Robin. This is Sarthak. Robin, I was trying to explore a scenario where there are 4 or 5 APIs. Response of one goes to other. There are some actions performed. Response of second goes to third. And there are some other actions performed. Response of third becomes a request for fourth, let us suppose. Or response of first becomes the request for third or fourth. Now, when these things might be coded, but when it comes to AI agent, how are we going to handle all those things together?
Yeah, 100%. I think that's a very good question. So at least in our case, and I can speak for my case, what we do is you can go to helper scripts and let's say we go to generate API functional gherkin test helper script, right? Here is a small sample of how to run it. But basically, you can give it your open API spec as a YAML file. You can specify which model to use and the number of test cases to be generated. So what this will do is it will read your open API spec, generate those end-to-end test cases in .feature format, and you can just feed it to the agent. Now the agent will not only run them. To your question, you can ask the agent to use the, let's say, access token from scenario 1 into the access token of scenario 2, or
Yes.
the endpoint value of 1 into 2. It will use that features storage to pass that value from one scenario to the other and then run that end-to-end scenario for you. So for example, even in one of our sample test cases, if we go over here and we go to the Salesforce leads one, right? Not very detailed, but basically you're trying to create a lead. On line number 6, what I've highlighted is that you enter the lead details from the data of user's API last record. So in this case, you are telling the agent, go hit that API, get the record details, and then create the lead with those things. So similarly, you can chain these values as much as you want.
Thanks. Thank you.
Yeah, sure. Okay. So Max is asking, how about taking the agents network we saw here to one level above and analyze project management tools and have them generate the test feature files? I mean, is this something in area of your interest direction you will grow eventually, or you focus only on the testing part? Okay, very big question. Very close to our heart. Definitely moving in that direction. The idea is that while this is the open source piece, we love the community, more than happy to help people run the execution part autonomously. The test generation feature is something that we're exploring in the SaaS offering that we have. We believe that it can tie to your Jira and then generate the test cases for you. So definitely yes, to I think 2 or 3 questions in this one question. Are we doing that? Not in the open source, in the SaaS offering? Is that something we want to do? Definitely yes, that is something we want to solve for. Okay, are there times when you need to give the agent specific locators, CSS or XPath? No, we would just ask the agent to interact with elements on the screen. So for example, over here, we are literally asking it to input for something should open, and on the search bar, do this one thing or select turtleneck as the filter. Interestingly, turtleneck over here is a small checkbox. It could be a radio button, it could be a drop down. The agent will figure out on the UI and then interact with it. So we don't provide it explicitly XPaths ever. Like no code, nothing, no locator ever is the idea. Okay. Does the agent remember what path it took on previous test? So it can read if anything has changed. It is not over here in the open source offering. The open source is stateless by design. The whole idea is that this is out for the community, for people to run and build trust on the system. We don't take any data. We don't save any previous step, test, path, anything. You can use it locally with your own LLMs is the idea. So the agent has no memory of anything, any wrongdoings it has done, or maybe even the good doings it has done. Okay. Andrew is asking, so like search by text, like in Playwright. Interestingly, it does use Playwright, but not in that traditional sense, wherein it is doing a search by text. What it will do is, for example, if we say user selects turtleneck as the filter, as I was explaining, the agent will, okay, where do we have the slide? The agent will actually get the DOM or get those elements, figure out that best locator for that executable plan at that moment of time, and then interact with it. So that the user does not have to worry about locators and writing scripts or anything of that sort. The agent will take care of it on its own. Okay, I might be going a little fast, but let me know if the answers are not clear, or maybe it's like midnight in India from where I am joining in. Okay, what happens when there are multiple items on the screen? You can tell it that, for example, on the screen, right? We see multiple yellow boxes, for example. You can ask it that click on this yellow box under this section. So one of the test cases that we have is, for example, on this website. So on this website, interestingly, as you can see, there are multiple buy sell quantity input boxes. So you can ask the agent that enter buy value as 50,000 under the delivery equity section. So it will figure out that on its own and then interact with it. So if there are multiple items, you can give it directions. Just like how you would tell somebody on your team that, go click on that one, not that left one, do it on the right one. Okay. How about the test results? We can see that the test is running, but are any results being saved when I run multiple tests? Yes, 100%. So for example, if we go here and we go to output and we see this quickly, for each run, we generate a small HTML file which tells you what test case was run, whether it was pass or failed, how much time it took, and then where are the other artifacts. Now, what are these other artifacts is what is interesting to me. For example, if you go inside the proofs folder, inside proofs, It will capture all the interaction logs, network logs, console logs, video screenshots. And also, something which I find very fascinating is the playwright trace. So you can just take that playwright trace, load it over here. Yeah, you can literally scrub through the whole execution. Not only that, it captures all the actions it took and an entire treasure trove of network interactions, consoles, errors from that execution session. So that is what you can look at the pass fail, and then if you want to debug something, you can take this and then work as deeply as you want from an engineering angle. Okay, cool. Thank you.
Let's give the folks another. Oh, there's the next question.
Okay, what Jose asked, I was trying to get to, there is no guarantee that the agent takes the same path on run. It's very hard to make a regression suit out of that. See, interestingly, one of the theses that we have is that, or maybe I can show it to you. So, for example, I'll show 3 examples of test cases, right? And we generally recommend people to follow one of these styles. So you can write very detailed steps, as detailed as enter the first name as test and add current time to it, or enter the last name as lead. So the agent will specifically follow this path. If it is not able to find the last name field, or it has changed, or it is not able to enter that, it will just fail it at that step itself. So that is the hard mode that we have in place right now. So it's like very strictly follow these steps only. Then you can be somewhere in the middle. Okay, select turtleneck as the filter. Now that turtleneck could be a checkbox or a radio button or a drop down. It will figure it out on its own. So that is somewhere in the middle. Or you can write very abstract test cases, like opposite of specific is abstract. Just create a lead on the system. So it will do whatever it can to create a lead on the system. What we recommend people is always start with this. Because when you start here, it will follow that path specifically. If it is not able to follow it, it will fail it. And that is how it will be a very good candidate for the regression suit. So that's how I think we can answer Andrew's question. Can I take this playwright and run it on my local development server? We actually don't generate any code out of it as of today. The idea is that the minute you generate code, it writes those XPaths and locators and commands and those things. If your UI changes, then again you are stuck in that maintenance loop for that code. So then the code becomes the source of truth rather than the test case. So we don't generate code, cannot be taken, cannot be run as of today. Are there any common pitfalls or challenges in multimodal validation that teams should watch out for when deploying them in prod? We've seen a few. For example, if the accessibility of the UI is not properly implemented, then the agent would have issues finding it out. Or for example, let's say there's a Gantt chart or there's a canvas element, which requires a lot of custom interactions like dragging, dropping, zooming in, zooming out, pinching, so on and so forth. You would have to explicitly tell the agent what to do, just like how you would tell me if I'm new to the team. So those are some of the common pitfalls that we have seen, wherein you would have to not just be very precise, the application has to be conducive for agentic testing. Okay, what about hallucinations? Will it probably check a test even if it fails? Have you seen something like that already? Hallucinations, we have seen many. Will it check a test even if it fails? In this, let's say, test case example, which I'm showing on my screen, right? Let's say, based on the most recent deployment, the first name field was removed. Now, in that case, the agent believes that it should enter something in the first name field, but it is not there. So what we have seen is that if the test case is not updated, the agent will still try to run it word by word and then fail that test case. It might hallucinate if the instructions are not clear. A lot of times, for example, there is a drop down or a select field. People would write enter Robin in that field, which is actually a drop down value or select value. Now, since you told it to enter, it will assume that it's an input text field or something. And then it will go in loops and try to figure out what's happening. It will try clicking here and there. And then finally, after 5 clicks or so, understand, oh, looks like a select dropdown. Let me click this value. So those are some of the places that we have seen some fun moments for humans and agents. Okay. Let's take the create a lead test as an example. It is so abstract. So what would be actually the condition to fail it? How long the agent will try to click different buttons to try to fulfill the objective. Okay. Interestingly, that test case is one of the worst examples of test cases somebody can write. But again, it has that magical touch to it, so we show it. We don't recommend people writing test cases in this way. You can write it. The idea is that in the open source offering, it does not have the memory or the context of the application. When the SaaS offering, it has that. So there, that context, that abstract test case would make sense. But to Mac's point, this is so abstract, the value is questionable here. So we don't recommend this style. How many times will the agent try? So generally, we try for 10 attempts of doing something. But again, this is open source. You can fork it, download it. You can change it to 9 or 25 or 2 or whatever. So that's up to the user to some extent. Okay, is the decision has to be static or can it be randomly taken from a file? Yes, yes to both. You can do a small test data file. As I was highlighting earlier, you can also attach a small API spec. I don't think I can find one in time. But to your question, you can provide test data, either a text file or even a JSON YAML OpenAPI spec would do. So both ways, yes. Thank you.
Let's give it another try. Let's wait for one more question, maybe.
Yeah.
And yeah, meanwhile, thank you for the good presentation. It was fun. It was short, and you had the hardest part answering the questions.
Yeah.
So thank you for that. Let's see, maybe someone is still typing.
Okay. Thank you. Okay, GitHub repo is on the screen. Can I take this? Okay, I think I can take it. You can find the repo here. You can also find a Slack channel on that GitHub repo wherein you can ask more tough questions.
Right. I will hijack the screen now. And see. It should be the right one. All right. Then again, thank you, Robin. I hope it was fun for you as well. And yeah, hope to see you sometime soon when you show us the auto test writing tool.
Yeah, definitely. Yeah.
Yeah. Thanks everybody for joining and have a good night.
Yep. Thank you, everyone. Have a nice one.
Thank you.
Thank you.